Good afternoon to all of you. We are discussing the finite automata with output. So, finite automata with output means after giving certain input string, we are getting the automata with a certain output, right? So, there are two types of finite automata with output. The two machines are there. That is nothing but first one is nothing but the Moore machine, and second one is nothing but Mealy machine. So in case of your Moore machine, the output of the machine, it is totally depend upon the state. Means you can draw the state, for example Q0, and output is associated with that particular state Q0, and it is drawn inside the circle of that particular state in case of your Moore machine. While in case of your Mealy machine, the output is associated with the input as well as the transition from one state to the next state. Means there are two parameters that are going to decide the output in case of your Mealy machine. Getting this point? So and there is a possibility that we can convert the Moore machine to the Mealy machine and Mealy machine to the Moore machine. So that we are going to see in the today's session. So see here, equivalence of Moore and Mealy machine. Moore and Mealy machines are considered to be finite automata that are capable of generating desired outputs. So we can say that yes, these are the automata where they can able to produce certain output, because which is not in case of your DFA or NFA, where these automata, your deterministic finite automata or non-deterministic finite automata, they are purely referred as your language acceptor or language recognizer. Output, we are not getting out any sort of output from the DFA or NFA, but we are getting the results whether the particular string is being accepted by the language or not. That is the case, right? So, but in case of our Moore machine and the Mealy machine, yes, here we are getting certain output. We are inputting some string. For example, if we input the string like AB, so and it gives you certain form of output in both the machines, whether it is a Moore machines or whether it is a Mealy machine. Getting this point? So this is the possibility. But machines generate the same output string for the same input string. Meaning is that both machines generate the same output string. So for example, same output string for the same input string. Suppose I enter suppose AB. So whatever may be the output, say for example 1010, the same output is being displayed by the both of the machines, whether it is a Moore or Mealy machine. Means you are not getting the different output for the same input string. By using these two different machines, you are getting the same output here. Thus, Moore machines can be converted into, means the meaning is that they are equivalent. If we see their equivalence, they are equivalent. Their powers are equivalent. Only the thing is that their one can say that their drawing or how they can be drawn is the only different method, but the final output is the same for both the cases, right? So we can have the conversion from Moore machine to the Mealy machine, and vice versa, that is from Mealy machine to the Moore machine is also possible. In the today's session, we are going to discuss the conversion. The first point we are going to cover conversion of Moore machine into the given Mealy machine, right? So see here the methodologies, how to convert the Moore machine to the Mealy machine. So there are steps are given how to convert, how the conversion takes place here. So we have to just go through it, and you will come to know that the method is very simple. It is very easy to convert given Moore machine to the equivalent Mealy machine, right? So see the steps here. In Moore machine, the output is always associated with the states. That, as you know, that in Moore machine, the output, for example Q0, and output is 1, so output is always associated with the states. But in case of while Mealy machine, the output is associated with the inputs. Means in case of Mealy, if I have to draw this one Q0 Q1, so this is your input and this is your output. So this output is associated with the input and the transition from Q0 to Q1. This is the case. So we will develop a procedure for transforming a Moore machine into Mealy machine in such a way that for a given input string, the output strings are the same in both the machines. So that is obvious though you are going to input different machine, though you are going to input the different same string for different machine, same string for the Mealy as well as the Moore machine, the output must be the same. Output must be the same. The definition of Moore machine you know very well, that is M equal to Q sigma capital delta small delta lambda and Q0, where Q is nothing but the finite set of state, sigma is the input alphabet, capital delta is nothing but the output alphabet, small delta is the transition function, and lambda is nothing but the output function in Moore machine, and Q0 is nothing but the start state. Q0 is nothing but the start state. So you can have the definition of delta given for Moore machine, and for the Mealy machine also definition of delta you can find the transition function Q into input gives you Q, where in this case Q into input in Mealy machine also the definition for delta is same, but the definition of lambda function, that is output function, is different in this particular, in both the machines, where here you are getting Q gives you the output, but here Q into sigma, Q into input gives you the output in case of your Mealy machine. So what we have to convert here, the output function in Mealy machine is obtained as, so while converting this Moore machine to the Mealy machine, what we have to find out here, we have to find out this lambda dash function. We have to find out this lambda dash or output function. And how to find out this lambda dash function? So given here is that lambda dash into bracket qa, where q is the state, a is any input, a is the input, is equal to lambda. See here carefully, is equal to lambda into bracket delta qa, again state and input, that is equal to lambda 1, means it is nothing but the output associated with the state q. Means we have to find out the output associated with the state lambda. We have to find out the output associated with the state lambda, right? So we can say that Moore machine, it is defined by m, whereas Mealy machine defined by m dash. And which are the two entities they are changing here? The delta dash function is being changed here, and lambda is getting changed here. In case of Moore machine, it is a delta, but in case of Mealy machine, it becomes now delta dash. Whereas in case of Moore machine, the lambda is here, now it is being changed to lambda dash, means these two values or these two parameters are being changed here. While converting, we have to convert only these two parameters. The rest of the things, q, sigma, capital delta, and q0, they remain same. They remain same for all these four parameters. Getting this point? So we have to convert these two parameters only, small delta and lambda function, that is nothing but the transition function and the output function. So how it is converted? So see here, convert directly, we'll see example, so which will becomes more clear the concept. So example is given here, convert the following Moore machine into its equivalent machine. So Moore machine, the transition table is given. So q0 on 0 goes to q0, q0 on input 1 goes to q1, q1 on 0 goes to q2, q1 on 1 input goes to q0, q2 on 0 goes to q1, q2 on 1 goes to q2 state. And the output associated with this state q0 is nothing but your 0, output associated with the state q1 is nothing but 1, and output associated with the state q2 is nothing but 2. So there are three output alphabets, we can say 0, 1 and 2. So from this transition table I can have the transition diagram of Moore machine, or we can draw the given Moore machine. So this is the same. So from this transition table I have drawn here the transition diagram. So q0 output is 0, q1 output is 1, and q2 output is 2. So how many output alphabets are there? You can have there 0, 1 and 2. And how many input alphabets? Input alphabets are only 2, 0, 1. What is the set of q, capital Q, q0, q1, q2? Getting this point? So I identified this capital, and q0 is nothing but the start state here. So q0 is there, capital Q consists of three states, q0, q1, q2. Then you have the inputs are two inputs 0, 1, and output are 0, 1 and 2. These are the given here. So you have to convert this Moore machine, you have to convert into the form of Mealy machine. So this is the first step to draw the diagram. Then the output function lambda dash, it can be obtained as lambda dash equal to q comma a, that is equal to lambda into bracket delta qa. So this is nothing but your Mealy lambda dash, Mealy lambda dash output function. This is nothing but your Moore lambda function, output function. Getting this point? So how to calculate this? Hence, we will obtain output for every transition corresponding to each input symbol. So for each input symbol, you have to find out the lambda delta transition first, and then you have to go for the lambda, right? So how it is, just see here, lambda dash. So take the first state, that is nothing but your q0. The input symbol is nothing but your 0. What is equation? Equation says that you take lambda into bracket delta into bracket q0 0. So delta q0 0. What is the value of delta q0 0? This value is nothing but your q0. So if you want to say it, delta q0 0 means transition of q0 on 0, it goes to q0. That's why it is written here. q0 0 is nothing but lambda q0. And what is the value of lambda q0? Lambda means it is value of output. What is the value of output? Value of q0? It is 0. That's why written as a 0. It is point. So it is very simple. Then lambda dash q01, that is equal to lambda delta q01. Lambda into bracket delta into bracket q01. So first find out this entity, that is transition of state q0 on input 1. So transition of q0 on input 1 goes to q1. Then find out its output value. Lambda is nothing but your output. So output of lambda q1 is nothing but your 1. That's why written as a 1. So next, now state q0 and both inputs are over for this. Okay, this is okay. 0, q0 on 0, q0 on 1. Now take the next state q1, input is 0. So you have to take all inputs and you have to take q0, q1, q2. So 3 plus 3, 6 transitions must be there, or 3 into 2. So 2 into 3, that is equal to 6 total transitions you have to write down here. So meaning is that, so delta dash, we are finding out this lambda dash transition. We are finding out the lambda dash transition. So lambda dash q0, lambda dash q0 0, lambda dash q01 is over. Now lambda dash q1 0 is equal to lambda into bracket delta q1 0. Delta q1 0. What is the value of delta q1 0? It is nothing but q2. It is from the transition graph or transition table. And what is the value of lambda q2? Lambda q2 is nothing but your 2. So we are finding out this entity. Yeah, we are finding out this one, right? Lambda, the value of this lambda dash q1 on what will be the next value? Next value will be lambda q1 on 1. That we have to find out. So how to find out lambda into bracket delta q1 1, right? So what is the value of delta q1 1? Delta q1 1 value you have to find out. That value you have to put in the lambda. So it is written here, q1 1 is nothing but q0. And so what is the value of lambda q0? Lambda q0 is 0. So this is lambda dash q1 dot 1 equal to 0. This is my answer, right? What I am finding here. So in the same manner, I have to find out here lambda dash. So okay, q1 on 1, q1 on 0, q1 on 1 is over. Now q2 on 0. So that is equal to lambda into bracket delta. See here, lambda into bracket delta q2 on 0. That is equal to lambda delta q2 of 0. What is the value of delta q2 of 0? So delta q2 of 0 is nothing but q1. So I can write here q1 lambda q1. And what is the value of lambda q1 is nothing but 1. So I can write here, therefore lambda dash. So here on PPT I have make it in a shortcut format. But while writing in notebook, you have to write down these steps. Lambda dash. So here I have make it in a single line. So this single line you can have the 3 lines. 0, that is equal to 1. So this answer it is correct. So all these answers are correct, but only the thing is that they are written in the single line here. So same way, q2 on 1 you have to write here, q2 on 1 lambda delta into bracket q2 1, that is equal to lambda q2, that is equal to 2. So from these transitions you have to draw the transition table. You have to draw the transition table, and the final transition table for the resultant Mealy machine becomes. So here you have to add the 2 columns here. For input 0, you have to add the state and lambda, that is output column. For input 1, you have to add the state and output, right? Output column, right? So states q0, q1, q2. States q0, q1, q2. The same state you have to copy here, q0, q2, q1, and the state q1, q0, q2. The states, same state you have to copy as per the given Moore machine, because here states are not going to change here. So in a simple way, so see here the transition table for the given transition table in the Moore machine. So the shortcut way, what we have to write do here. So this Q0, Q2, Q1 for input 0, and Q1, Q0, Q2 for input 1, for 0 input and for 1 input, you have to just copy this in that particular table. You have to just copy it, right? So this is the method, what shortcut method. So see here, these are the values. So these are the values. So these states for input 0 state, you just copy it from the given Moore machine table, right? In case of for input 1, the state value Q1, Q0, Q2, you have copied it. Now these output values, these are the values 0 to 1 and 1, 0, 2. These are these 6 values which we have calculated just now, right? So Q0, 0, Q0 on 0, Q0 on 0, right? Q0 on 0. What is the lambda value? Q0 on 0. Lambda value is 0. So this value is put here, right? Q0 on 1. What is the output value for this Q0 on 1? So lambda dash Q0 of 1 is value is nothing but 1. So that's why it is written as a 1 here, right? So Q1 on input 0, Q1 on 0 value is 2. So Q1 on 0, Q1 on 0 is nothing but your 2. That's why 2 is written here. Q1 on 1, Q1 on 1, it is written as 0. Q1 on 1, it is equal to 0. That's why 0 is written here. Now Q2, transition of Q2 on input 0. So output is 1 here. That's why 1 is written here. And Q2 on 1, Q2 value, Q2 transition on 1 input. So Q2 transition on input 1, output gives you 2. That's why 2 is written here. So these are the 3 plus 3. These 3 and these 3. These are the 6 transitions. Just we have to find out, means while converting our Moore machine to Mealy machine, it is very simple. There is no any difficulties involved. Only you have to find out the what we have to find out here. Lambda dash we have to find out. Lambda dash is nothing but the output associated with each state. So here for Q0 for input 0, the output is 0, but for Q0 for input 1, output is 1. And this we have find out with the help of these transitions, right? So next point or the next step is to what we have to do here. We have to draw the transition diagram of equivalent Mealy machine. Means finally we have to draw the Mealy machine. So see here how it is drawn. So if you draw this transition table, then it becomes very simple. Once the transition table you have, from the transition table, this diagram is very simple. So Q0 on 0. So this is nothing but your input. This is input, and this one is nothing but your output. This is again your input, and this one is nothing but your output, right? So Q0 on 0, Q0 on 0, it goes to Q0 and output is 0. So Q0 on 0 goes to Q0, where is output is 0 itself. Getting this point? For example, Q1 on 0 goes to Q2. So Q1 on 0 goes to Q2. Here Q2 goes to Q2 and output is 2. That's why output is 2 is written here. Getting this point? For example, Q2, again suppose Q2 on 0. Q2 on 0 goes to Q1 state and output lambda is 1. Q2 on 0, input 0 goes to Q1 state and output is 1 only. And output is 1 only, right? So this is the way how to draw the resultant Mealy machine. This is way how we are actually drawing the Mealy machine. This is the correct answer. And always there is a examination. There is 101%. There is a question on conversion. Either convert the Moore machine into Mealy machine or Mealy into Moore. One question is compulsory is asked in semester as well as in the end semester examination. Getting this point. So let us go to another example. Convert the following Moore machine into equivalent Mealy machine. So see here, number of states are 2 states Q0, Q1. The inputs are A and B. Input are A and B, and the output also with Q0 is 0, and with Q1 is 1. So transition diagram is drawn. So very simple diagram. Only 2 states are there, Q0, Q1, and their transitions are drawn here. Q0 on A goes to Q0 itself, whereas Q0 after applying B input goes to Q1, and output of Q0 is always 0 and output of Q1 is always 1. So this Moore machine we have to convert into the Mealy machine. So the output function lambda dash we have to find out, and how to find out this with the help of this equation lambda dash into bracket q, where q is the state and a is nothing but any input, that is equal to lambda into bracket delta into bracket means we have to find out the transition delta of q on input a. So hence we will obtain output means lambda for every transition corresponding to each input symbol. So say same case here, so lambda dash q0 on input a and lambda dash q0 on input b. The same way, how many states are there? There are two states q0 q1 and there are inputs are a and b. So there are how many possible transitions? There are only 4 possible transitions are there. So q0 on a, so the lambda delta q0a, what is the value of q0a? That is the q0 itself, and the lambda of q0a is equal to 0, right? Next q0 on b, so delta q0b, what is the value of q0b? Q0b is q1, and now what is the value of lambda q? Lambda q1 is 1. Now same for q1a and q1b, so we have find out this q1a 0 and q1b is 1. The transition table is drawn here. So for input, because in case of Mealy machine you have this transition table. In case of Mealy machine, this transition table for input A you have to write down the state and in output alphabet or output. For input B also you have to write down the state and output you have to write it down. So Q0 Q1, so states are Q0 Q0, and for input A and for input B, so these states are copied from the given table. Remember this point. This is just a method. This is nothing but the this one can say q0 q0, it is just copied from there, and q1 is also copied from the Moore machine table. Only the thing is that this thing you have find out just now. So q0 on 0 gives you 0 and q1 on 0 gives you 0. So this is, these two zeros are placed here, 0 0, and this is the 1 and this is 1. So this is here 0 1 and 1. Getting this point? And finally, so we can have the diagram of equivalent Mealy machine. Right, simple one, no any difficulties involved or no any critical mathematics is involved. Only the thing is that you have to follow the particular method. So q0 input A, output is 0, state is q0. Q0 input is B, output is 1, but the next state is q1. Q1 input is B, output is 1, and the next state is q1 itself. Whereas q1 after applying input A, it produces output 0 and state changes to q0 in case of Mealy machine, right? So this is our correct answer for the Mealy machine, right? Let us see another example. Convert the following Moore machine into equivalent Mealy machine. So yes, now here 4 states are given, q0, q1, q2, q3, and the lambda, that is nothing but your outputs are q0 always giving output is equal to 0, q1 output is 1, and q2 q3, these two states are the always giving output is equal to 0. So first draw the transition diagram for the given Moore machine. The transition diagram means q0 q1 q2 q3 and their respective transition given the transition table are drawn. This is the Moore machine, and let us start converting it into. First, finding what we have to find out here, we have to find out the lambda dash. Lambda dash we have to find out. So the output function lambda dash can be obtained by lambda dash q comma a, that is equal to lambda into bracket delta qa. Hence, we will obtain output for every transition corresponding to each input symbol. So let us find it out. Lambda dash q0 on 0, q0 state on 0 input, that is equal to lambda into bracket delta q00, that is equal to lambda q3 0, then q0 on 0 the same way, then q1 on 0, q1 on 1. So each state on each input we have to find out. q2 is the state, q2 on 0 1 and q3 on 0 and q3 on 1. So all how many transitions are there? There are total 8 transitions are there. Total 1 2 3 4 5 6 7 8, total 8 transitions are there, right? So according to all these transitions, so delta q0 0, so value of this delta q0 0 is nothing but q3, and total value of lambda q3 is 0, right? Then same way, so delta q00, value of transition q0 on 1, goes to q1, So find out now lambda q1. Lambda q1 is 1 given in the table, right? Then this delta q01. What is the value of transition function delta q1 0? That is nothing but q1. Now what is the value of lambda q1? Lambda q1 is nothing but 1, right? So in this way we have to find out all these transitions. So remember here, how many states are there? q0, q1, q2, q3. These are the states, and the input symbols are 0, 1. So there must be 4 into 2, that is equal to 8 transitions are possible. Getting this point? So once you find out all these transitions, once you find out the output for all these states, all these one can say the transition lambda dash for all these transitions, you can have the transition table. So we can write down the transition table. So see here how the transition table for the Mealy machine is written here. So on input 0 you have state and output, on input 1 also we have the state and output. So as per our methods, this is the same as in case of your given Moore machine. You can copy from the Moore machine table, and what we have to write here, you have to write down this column out input 0, input 1 for this. So q0 on 0, q0 on 0, the lambda is nothing but 0, that's why 0 is written here. Now q0 on 1, lambda is 1, that's why it is written as 1, right? Next q1 on 0, the lambda is 1, that's why it is 1. Now q1 on 1, lambda value is 0, that's why it is written as 0. And all other q2 0, q2 1, q3 0, q3 1, so all these are 0, 0, 0 and 0, right? So this is the transition table for the resultant Mealy machine. So once the transition table is clear, so you can draw the transition diagram here. So how to draw the transition diagram? So see here. So this is the resultant transition diagram q0, q1, q2 and q3, right? So q0 on input 1 goes to q1. So q0 on input 1 goes to state q1 here, and output is 1, and output is 1, so you have written here output. So always do not get confused. From starting I am telling you that do not get confused. The first entity is nothing but your input, and this second entity is nothing but your output. So how to read this? You have to read like this: q0 on given input 1 goes to state q1 and produces output is equal to 1. So see here, q0 on input 1 goes to state q1 and produces output equal to 1. This is always the case. q0 on input 0, for example, on input 0, this is input symbol, goes to state q3. So that's why it is goes to state q3 and produces output equal to 0 and produces output 0. That's why this output is 0, right? In the same way, for all the states q1, q2, q3, all the transitions as per the transition table we have to draw here. Getting this point? It is nothing difficult here, or not a very critical issue here. Everything is simple. Let us see one more example. Convert the following Moore machine into equivalent Mealy machine. Now the transition diagram is given here. So examples we have seen so far. Transition tables are given and we draw the transition diagram. But now here transition diagram is given. So first we draw the transition table for the given Moore machine. So A, B, the two inputs are there and states are Q0, Q1, Q2, Q3. These are the four states, right? These are the four states. So Q1 and their transitions. So these transitions are useful. These A and B transitions are useful while drawing the transition table for the Mealy machine. While drawing the transition table for the Mealy machine, the only thing is that we have to find out there. We have to find out the lambda dash function for the resultant Mealy machine, right? So the output function lambda dash can be obtained by lambda dash qa, that is equal to lambda into bracket delta q comma a. Hence we will obtain output. Hence we will obtain output for every transition corresponding to each input symbol. So how many, again there are, how many states are there? These are the four states, and the input are a comma b, that is two inputs. So total transitions are 8 transitions. We have to write down the lambda dash transitions for 8 different transitions. So see here again q0a and q0b, same case. q0a state q0 on input a and q0 on b. So you can have lambda delta q0a, lambda delta q0b. Now value of delta Q0A, what is the transition of Q0A from the transition table or the transition diagram? You can find that Q0A is nothing but your Q1. And now once this Q1 value you find it out here, you have to find out the lambda Q1, and lambda Q1 is nothing but your 1 value, right? Then delta Q0 on B, delta Q0 on B is answer is Q2, and find out the lambda value of Q2 is nothing but 0, which it is already given. It is given in the transition table or the transition diagram. Getting this point? So all these things are given. So if you want to check it, so Q0 on A, Q0 on A that we are checking here, Q0 on A. So Q0 on A, it goes to Q1 state. It goes to Q1, and what is the lambda of Q1? Lambda of Q1 is nothing but your 1. This is the lambda Q1. This is the lambda Q2, right? This is the lambda Q2 value. This is lambda Q3 value. This is lambda Q1 value, and this is lambda Q0 value. These are the, because these are the outputs. These are the outputs. They are associated with the states. These are the outputs. They are associated with each states. That's why they are, lambda means output of Q0, output of Q1, output of Q2, output of Q3. Getting this point? The simple, nothing is difficult here. So then take Q1 state, Q1 for input A and Q1 for input B. So we'll get here Q1 on A, it is nothing but Q3, and lambda value of Q3 is nothing but 1. Now delta Q1B is nothing but Q2, and what is the lambda value of Q2 is nothing but 0. Then go to the Q2A and Q2B. So we'll find here this way. So these are the transitions, and final state is nothing but your Q3A and Q3B. So total transitions are 8. So these are the values we found out: 1 0, 1 0 1 0 0 1 1 1, right? So accordingly we have to write down the transition table. So see here, the transition table can be drawn as for input value, input A, and for input B. So Q0 on A go to Q1. So these are the same. These states are same, because state transitions are not different in both, same in both machines. It is not different. Only the thing is that we have to find out this lambda A for A for Q0, and lambda for B on Q0, Q1, Q2. That we have found out. Q0 on A, Q0A, lambda is 1. So that's why 1. Q1 on A is 1. That's why it is 1. Q2 on A, input A, Q2 on input A. That's why 0. It is 0. Q2 on A, it is 0. That's why it is 0 here. Then Q3 on A is nothing but 1. That's why it is marked as a 1 here. So this is the same way. So once you have written the transition table correctly, so this value, so once you find out this value correctly, then your transition table will become correct. And once your transition table is being correct here, then definitely your transition diagram of the resultant Mealy machine will be the correct one. There will be no any mistake, or there will be no any error occur in drawing the Mealy machine, right? See here. So transition diagram of equivalent Mealy machine is Q0, Q1, Q2, and Q3. These are the 4 states, and the diagram drawn in this way. Q0 on input A goes to Q1 state. Q0 on input A goes to Q1 state, and output is 1. So that's why this output is 1 is written here. Q0 on input B goes to state Q2. So Q0 on input B goes to state Q2, and output is 0. That's why it is 0 is written here, right? The same way, Q1 on input A, Q1 on input B, then Q3 on input A and B. So see here, Q3 on input A, Q3 output 1. On input B, again same state, Q3 and output is equal to 1 equal. So that's why A/1 and B/1. Input A, output 1. Input B, output 1 for same loop, let's say self loop for the Q3 states, self loop for the Q3 states. Getting this point? Okay, so that's all for this conversion. How to convert the, it is very simple to convert the Moore machine into the equivalent Mealy machine, right? So these are the some questions. The tables are given, the Moore machine given in the form of table. You have to first draw the transition diagram of the Moore machine, and straight away directly find out the lambda dash function. And once you find out the lambda dash function, and now for the transitions, then you have to write down the transition table. And once you write down the transition table, then you can have the transition diagram for the resultant Mealy machine. So these are the three questions. These are the three, one can say, transition table. This is the first one, this is the first one, this is the second one, and this one is the third question, right? So q1, q2, q3, the input 0 1 and the lambda is given 0 0 1. The second question q0, q1, q2, q3, input 0 1, inputs 0 1, and the output is 1 0 0 1 are given. And the third one is nothing but your states are p, q, r, s. The inputs are 0 1 and lambda are values for state p, it is 0, for state q it is 1, and for state r the value is 0, and for state s the output value is 0 here. So draw the transition diagram and then find out the lambda dash transition. Say for example, we can have this q0 comma 0, then you have to find out lambda delta q0 comma 0. So lambda q0 comma 0, q0 comma 0 is nothing but your q1. So I can have lambda q1 here. So what is the value of lambda q1? Q1 lambda is nothing but my 0. So I can write here 0. So in the same way, you have to solve these three examples, the three questions to convert Moore machine into the equivalent Mealy machine, right? Okay, so in the session, the topics covered are equivalence of Mealy machine, Moore machine, and Mealy machine, and the conversion. We have seen the examples and the methodologies how to convert the given Moore machine into equivalent Mealy machine. It is very important as far as your examination point of view. So course attainment to solve the problems in computing. Those are the standard reference book which you have to always refer it. So okay, so let us stop here for this today's session, right?